The overall goal of the following experiment is to investigate the dependence of friction and wear reduction on linear velocity in ultrasonic lubrication. This is achieved by first conducting tests on a modified pin-on-disc tribometer while recording real-time friction forces during the tests. As a second step, an optical profilometer is utilized to characterize wear, providing 2D and 3D profiles, surface roughness, and volume losses in the grooves. Next, friction and wear reduction at 3 linear velocities are quantified using measured friction forces and calculated wear rates. The results show that ultrasonic lubrication reduces effective friction force by up to 62% and surface wear by up to 49%. Friction reduction decreases as linear velocity increases, while wear reduction remains essentially constant at the 3 linear velocities considered.
Ultrasonic lubrication is a well-established technology for reducing and in fact controlling the effective friction coefficient between sliding objects. It works by vibrating one or both objects at ultrasonic frequencies, that is, frequencies above 20 kHz.
Ultrasonic lubrication has been implemented in manufacturing processes such as extrusion and wire drawing. Being a solid-state lubrication technology, it can be used in applications where traditional lubricants are undesirable, for example, in space.
To build the necessary tribometer, first assemble the chuck motor subsystem. Perform this assembly on an isolation table. First, level a DC motor with shims, and fix its position using struts and bolts. Then, position the support frame around the motor. Next, connect the spline shaft